Welcome you back for the sessions on the accumulators. See, as we know that the accumulators are the devices that stores the potential energy. See here in this case, it is storing the potential energy. There are some examples where it can. There are some examples even kinetic energy can also be stored. The best example for that is nothing but the flywheel. Here, the potential energy which is stored is utilized when it is required. A hydraulic accumulator is a device that stores the potential energy of a incompressible fluid held under pressure by an external source against a dynamic forces. The dynamic forces can comes from different sources. The storing of the potential energy in an accumulator is a quick secondary source of the fluid power capable of doing a useful work. The accumulators are classified into weight loaded accumulators, spring loaded accumulators, and as well as the gas loaded accumulators. Even the gas loaded accumulators are also classified into a non-separator and as well as a separator type of accumulators. Even in the case of the separator type of accumulators, it has been classified into piston type and as well as a diaphragm type and as well as a bladder type of accumulators. See, these are the broad classification of the accumulators, but in general it has been classified into weight loaded, spring loaded, and as well as a gas loaded. The first one what we are discussing is with respect to the weight loaded or the gravity accumulator. The schematic diagram shows the weight loaded accumulators. See here in the case of the weight loaded accumulators, as the name itself is suggesting that a dead weight is applied over the cylinder or the cylindrical portion where the fluid has been stored. It is vertically mounted cylinder with a large weight. When the hydraulic fluid is pumped into it, the weight is raised. The weight applies the force on the piston that generates the pressure on the fluid side of the piston. The advantage of this type of the accumulator is the constant pressure of the fluid is throughout the range of the motion. The main disadvantage of the extremely a large size of the dead weight is applied, and it is unsuitable for the mobile application. This is one of the major drawback with respect to the weight loaded accumulators, or it may be a gravity accumulator. The schematic diagram shows the weight loaded accumulator, or it may be a dead weight accumulator, or it may be a gravity weight accumulator. Here in this case, a dead weight is applied in the cylinder where the breather is there and a fluid flow valve is there. Okay, where the constant pressure, or it may be the constant weight is maintained throughout the operation. This is the what we can say the principle of the dead weight or it may weight load accumulator. The spring load accumulator is another type of accumulator where the energy is stored in the form of a compressed spring or by means of a spring force. The hydraulic fluid is pumped into the accumulator, causing the piston to move up and compress against the spring force. The compressed spring is then applies a force on the piston that exerts a pressure on the hydraulic fluid. These type of accumulators delivers a small volume of the oil at relatively a low pressure. Furthermore, the pressure exerted on the oil is not a constant one. It is something like what we can say it's a variable one, or it is something like a linearly a incremental one. But in the case of the dead weight accumulator, where the load applied or the pressure which is applied is of a constant one. As the springs are compressed, the accumulator pressure reaches its peak, and as the spring approaches their free length, the accumulator pressure drops to a minimum one. That is the it is linearly varying it. The schematic diagram shows the spring loaded accumulator. The spring pressure is applied on the piston, and the piston and as well as the spring, it is entirely placed inside the cylinder. The load is applied by means of the spring pressure, or it may be the spring load. The third one is the next one is nothing but the gas loaded accumulator. The gas loaded accumulator is popularly used in the case of the industries. Here the force is applied to the oil using a compressed air. In some cases, even the nitrogen is also used as the load bearing or the gas load accumulator. A gas accumulator can be a very large and is often used with the water, or it may be a high water based fluids using a air as a gas recharge. The schematic diagram shows the gas accumulator where the gas pressure is applied over the fluid flow. Here in this case it is not linearly, it is varying it. The fluid pressure is varying it. There are two different types of gas accumulators are there. In that also, the non-separator type accumulator and as well as the separator type accumulator. Here in the case of the non-separator type accumulator, the oil and as well as the gases are not separated by means of any membrane or by means of any media. Hence they are placed vertically. The separator type of the accumulator, here the oil and as well as the gas are separated by means of an element. Based on the type of the elements used to separate the oil and as well as the gas, it has been classified as follows. The accumulator selection is based on the so many factors. The accumulator selection is after ascertaining a type of the accumulator that is appropriate for the purpose. What remains to determine the volume of the form of the high pressure fluid. The accumulators are manufactured to a variety of the pressure ratings, and the one should choose be a rated pressure more than the maximum system pressure. The application of the accumulator. There are five basic applications of the accumulators where it is used in the hydraulic system. The first one is nothing but the accumulator is used as an auxiliary power source. The purpose of the accumulator is the application is to store the oil and as well as deliver it or the pump during the portion of the working cycle or when there is a drop in the pressure. The accumulator is then releases the stored oil on demand to complete the cycle and thereby serving a secondary power source. And as well as the pressure is maintained throughout the system. The accumulator is used as a leakage compensator. An accumulator can be used as a compensator for the internal and as well as the external leakages during the working conditions. The pump charges the accumulator and the system until the maximum pressure is reached and the pressure is switched on. The third application is accumulator is used as an emergency power source. In some of the hydraulic systems, a safety dictates that cylinder be retracted even though a normal supply of the oil pressure is lost due to the pump or it may be electrical power failure. In such cases, these accumulators are used as a emergency power sources. The fourth application is accumulators are used as a hydraulic shock absorbers. The one of the important application of this accumulator is the elimination of the hydraulic shocks or it may be normally the back pressures which has been created in the systems. The hydraulic shocks is caused because of the sudden stoppage or it may be deceleration of the hydraulic fluid flowing or relatively a high velocity in the pipeline. Rapidly closing of the valves creates a compression waves. These waves may fail the system or it may causes a problems or it may burst the hose pipes or these are all the problems which has been created. To avoid these problems, accumulators are used as a hydraulic shock absorbers. The another application is accumulators are also used as a thermal expansion compensator. When the closed loop hydraulic systems are subjected to heat conditions, both the pipelines and as well as the hydraulic fluids expands in volumetrically. Because of the coefficient of expansion of the fluids, the higher than that of the pipe material, this expands the volume. Liquid volume increases the entire system pressure. This condition may causes the pressure to exceeds the limit and as well as the safety and may damages the system components. For that reason, most of the accumulators are used as the thermal expansion compensator.